Hello everyone, this is lesson 4, where you take the previous 3 lessons, culminate into the hardest circuits that we're going to do in this project. Take a look, we have 3 resistors, R1, R2, and R3. We also know our R total, but we don't know our E total or our I total. Okay? Remember, what's special about our I total? It's the same no matter where it is in the series circuit. Where do you think we can start with this one? Well, I think we know most of this formula, but now I think we need to transpose. We don't know R2, but let's find out what R2 is. If we're transposing, R2 equals R total minus R1 minus R3. And for us, that's 14.05 ohms minus 4.5 ohms minus 6.75 ohms. And I get a total of 2.8 ohms. And that's R2, is it not? We can now move R2 over to here. Perfect. Now, there's nothing else we can solve right now except in resistor 2. And if we find I2, don't we find the I, the current, for the rest of the circuit? Let's do that right now. Let's use Ohm's law. I equals E over R, and in this case, we have 95.65836 volts over 2.8 ohms. When we divide that, we come up with a number of 34.1637 amps. And that is I2. Excellent. I'm going to move it over here because I want that information where I can see it. I think you know that, isn't this the same amperage as I1 and I3 as well? Doesn't it also live up here? So I total equals 34.1637 amps, which means that I1 is 34.1637 amps, and I3 is also 34.1637 amps. Excellent. If we have that information, can we figure out the volt drops for R1 and for R3? Let's use Ohm's law. What does it say? E equals I times R. So E1 is I1 times R1, giving me a number of 153.73665 volts. Then I come down to R3, and guess what? I can do E3 equals I3 times R3, which gives me a number of 230.604,975 volts. Well, we still haven't solved this circuit. Do you remember? We can now figure out what our E total is, because don't we have the volt drops that occur at each resistor? And this says we just add them together, the sum of them is going to equal the source. So let's do that. So E total equals 153.73665 volts plus 95.65836 volts. And finally, 230.604975 volts, giving us an E total of 480 volts. And where does that live? It lives at our source. Look at that. We just used all of our rules and a little bit of detective work to figure out what our E total was and what our I total was. Now we're going to do one more practice, and it's coming right up. All right, this is our last practice question, the ultimate test of our cerebral fitness. We need to figure out what the E total is and what the I total is and the resistance of each resistor. Let's take a quick look and analyze the circuit. We know the R total, which is fine, but we only know E1, E2, and E3 of our circuit. What does our rule say that we can do? We can take E total, find it by E1, E2, and E3. That would be my first suggestion. Let's find our E total. E total equals E1 plus E2 plus E3. Why don't you do that right now? I got a total of 24 volts. Now, as soon as we have this number, we want to move it back into the circuit. So let's put that right here. Remember, Kirchhoff said that the sum of the voltages equals the source. And that's what we have right here. Okay? Perfect. Now that we have a source voltage and we know our resistance total, can we figure out our I total? IT equals ET over RT. Perfect. What is our ET? 24 volts over 260 ohms. So we're dividing a pretty small number with a bigger number. We're probably going to have a decimal place. And I got a number for I total as 0.09231 amps. Excellent. Where does that live in our circuit? Well, doesn't it live up here? Does everyone remember current is unidirectional? I'm going to write that down, 0.09231 amps, which tells me that that's the same number at I1, 0.9231 amps. It's also the current at I2, 0.09231 amps. And guess what? Isn't I3 also our current total? 0.09231 amps. Excellent. We've figured out our I total and our E total so far. But now we need to solve for R1, R2, and R3. We can go back to Ohm's law and do R equals E over I. Let's do that over here. R equals, let's do R2. E2 over I2. I got a number of 120 ohms. Excellent. Now I can do the same thing over here, can I? I can do R3 equals E3 over I3, giving me a total of, I got 60 ohms. And then finally, R1, let's figure that out. It's R1 equals E1 over I1, and I got a number of 80 ohms. Did we just solve this whole circuit? Absolutely 100%. And all we did was use 3 of our series rules and 3 of our Ohm's law formulas. You see that? Amazing. I hope you were able to do that all yourself on your calculator and follow me along as you went. If you have any questions about anything we've covered in the last 4 lessons, I'd love for you to leave me a message, and we can discuss further in the notes. Thank you for joining me for today. I've really enjoyed teaching you series rules and Ohm's law. Have a great day. Talk to you soon.